Section 14.4, Dissociation Constants for Acids and Bases. Go and check out video problem 81 when you're done with this. So in the last video we talked about strong and weak acids and bases, and of course if you have a system in equilibrium you can write a dissociation constant. So in this case we're talking about a Ka value where A stands for acid. So we just got done talking about equilibrium. Here we're using equilibrium again. Or if it's a base you're going to look at a Kb value where B stands for base. Alright, so here's the example. HCHO2, right, it's in equilibrium. So we can write an equilibrium expression, which is going to be right here. Right. Remember, only aqueous and gaseous reactants and products. So H3O plus, CHO2 minus goes on top, HCHO2 goes on bottom. We do a lot more work with this in AP than what we do in this first year course here. So just be aware that you're going to see this again in AP. Alright? So here's for a base. The key part, the important part of both of these equations is, in this case, the hydronium ion, which is often shown as the hydrogen ion. In this case, the hydroxide ion. Okay? So here are some common weak acids and weak bases, and here are their Ka and Kb values. You can see they go from, relatively large Ka value to basically none of that breaks up. Alright? And here's this chart, characteristics of acids and bases. Pretty good, summarizes it fairly well. Alright? But again, looking at that sample problem, I think you'll be okay with what we need you to know here, which is, for the most part, realize that they exist, realize that we can write an equilibrium expression for them. Okay?